Right, we've solved, the very first thing we did was solving exponential equations with bases that were related, because that builds on something things you've done in the past, and it doesn't require any understanding of logarithms. Then you learn something about logarithms and logarithm laws. Then you could solve exponential equations because you knew what some of those laws were. And now we're going to do the inverse, equations that involve logarithms. What you just did now, or what we did, was solving equations that were exponential, but you needed logarithms to solve them, right? If you're solving for something that has an exponential expression in it, you need logarithms to solve it. If you're solving for something that has logarithms in it, what do you think we're going to have to do at some point? Like up here, this is the inverse of exponential expressions, right? You got to use the inverse to solve an equation. You've known that since grade 8, right? If you had x plus 5, and I'm not trying to insult your intelligence here, but if you have that, it involves addition. In grade 8, we could have said, now we're going to solve addition equations, but it wasn't necessary to give them fancy titles like that. But if you have an equation that involves addition, the operation you need to solve that is the inverse, subtraction, right? It's the same as any other equation you have. If you have square root of x equals 8, you need the opposite of that, the inverse, squaring both sides. So if we're solving, when we were solving exponential equations, you needed logarithms. Exponential equations, you need logarithms. Now you have logarithmic equations, you're going to need exponents, you're going to need anti-logs, okay? Okay, you'll use the anti-log. That's what people call it because otherwise it's hard to say what you're doing. Like all the other operations I just reminded you of, x plus 5 equals 8, it's easy to say I'm subtracting 5 from both sides, or I'm multiplying by 3 on both sides, or I'm square rooting both sides. It's not so easy to say. We'll try to describe it with words, and we'll see why they call it the anti-log function in a second here. You're going to need some of your logarithm laws first. Just like here, we had to, you can't take, again, I'm going to scroll back here for a sec. When you're taking the logarithm, I think you guys found out that you can only take the logarithm of the entire thing here. Because you ran into some difficulty with equations like this when you tried to take the logarithm of part of it and move this out in front of part of it. You can only take the logarithm of the entire side at once. Just like square rooting, you can only take the square root of an entire side. Here you can only do the anti-log of the entire side. So you can't say, well, there's these things I can get rid of by going anti-log. You can't do this. You can't say 10 to the power of that, 10 to the power of that, 10 to the power of that. You can't do each term individually. Just like you can't say if you have 3 squared plus x squared equals 5 squared, you can't square root each of those terms individually. You can't say square root, square root, square root. It's not true anymore, right? But you can do the square root of the whole thing and the square root of this whole thing. You can anti-log this whole thing after you put them together. How can you put this together? What can that be equivalent to? 2 logarithms added, you can make it logarithm of 140x, right? And then we have a 3 here. So that's simplifying that side. Once you have a single term here and a single term here, then you can work on getting rid of this. And just like anything else, you use the inverse. The inverse of taking the logarithm, right? The inverse of the logarithm button on your calculator is this button. They call it the anti-logarithm button because that's a lot shorter than saying what we're going to do here. What you're going to do is you're going to put a big 10 underneath here to say you're raising whatever's on both sides. You're raising 10 to the power of what's on both sides. It's hard to describe. It's a lot easier to just say, I'm going to take the anti-log of both sides. Otherwise, you got to say 10 to the power of whatever's on both sides, and it doesn't sound very mathematical. It's easy to say the square root of both sides, squaring both sides. The reason that this works is because then you have this cancels out nicely over here. Those are inverses. And you have what? On this side you have 10 to the third, which is 1,000. On this side you just have 140x. I know that people get troubled sometimes when things are small and then they are written in big form and vice versa. Like you might have been troubled by that when we worked with this exponential equation. It's taken me a lot of years to realize that that's something that troubles people. It's just the notation. When you write it as an exponent, you write it small. When you write it as a regular thing in front here, you write it big. That's just notation. There's nothing different about what kind of a number it is or anything like that. On the calculator, you'd write it all big in a lot of calculators. Then you've changed it. You've reduced it down to a linear equation that you can solve. So this is just 1,000 over 140, or 100 over 14, or 50 over 7. Right? The solution's down here. It doesn't matter to me whether you put it in lowest terms or not. You can. You can always put in your calculator to put it in lowest terms. Excuse me. That makes for a good video. If you have whatever calculator you have, you probably have a fraction key of some sort. If you want to use that to change things to lowest terms, I don't want us to sweat over putting things in lowest terms. You can leave it as 1,000 over 140 if you want, or we don't want that. You can, if you did 1,000 divided by 140, and there's a fraction thing here, fraction. It'll put it in lowest terms for you if you want. Some calculators you can set them so they always put it in lowest terms. Anyways, this is the key to this whole thing, is using the anti-log. That's the new concept. The rest of it's going to be, just putting in place some of the other things that we know. Okay. As a summary here, the key is to just realize that you use the inverse like any other equation solving you've done. Okay, you need to use the anti-log. Okay, anti-log function. Just because it's the inverse. Now, there's a couple questions I'm going to scroll back up here. There's a couple questions here that are worth thinking about. You probably didn't ever talk about restrictions with equations until you started working with some square root equations, radical equations. Like when you have I'll go back to my grade 8 one here. When you have an equation like that, are there any restrictions on what this can be, this variable? Is there anything that's not allowed to be there? This can be all real numbers, right? No restrictions. As soon as you do something like this, square root of x equals 10, what are the restrictions on this? Before we even start to solve it, what are the restrictions on that x? It can't be negative. It's got to be greater than or equal to 0, right? You looked at other equations likely in grade 10, like, x plus 3, x minus 5. You looked at expressions and said, what are the restrictions on that variable? What are the restrictions on x in that kind of equation there? It can't be 5, right? Sometimes you have equations where there's restrictions. Logarithm functions are like that in equations because there's certain things that they can't be. When you were playing around with the logarithm button, if you have something that says log x, what are the restrictions on that variable? What are you going to get an error for if you hit logarithm of that? If I do logarithm of 21, it's fine, right? If I do logarithm of 0.02, it's okay. As soon as I do logarithm of 0, it's undefined. Or if I do logarithm of negative 5 or something like that, You can't, there's no, logarithms of negative and 0 are undefined. So for your logarithm function, this has to be greater than 0. Can't be 0, can't be negative. Now it's going to be like anything else here. You guys were clever enough to say, for this one, you didn't say x can't be 0 there. You thought about it and said this whole thing can't be 0, which means x can't be 5, right? It's going to be the same thing here. If we look at an equation that, going all over the place on the page here, if we look at an equation that has something else, like if I was to say log of x minus 5 equals, this is an extra example for you before we get going on this crazy one here. Maybe fit this in somewhere because it's a lot simpler. And the idea of the restrictions here. Log of x minus 5 equals 2. How about that? If we're going to solve that and we want to look at restrictions, what restrictions are there on the variable there before we even start? What should we notice? What can this be? What can't it be? It can't be 5. Is that it? Is it just x cannot be 5? Yeah, it can't be less than or equal to 5. So in other words, it's got to be greater than 5. If you put in, think about it, if you put in a 4 there, what results inside the brackets? 4 minus 5, you get negative 1. You can't have that, right? If you put anything smaller than 5, 1 or 0 or negative, you get a negative number in there. Even if you put 5, you get 0. It has to be greater than 5. It could be 5.0001 if you want. It has to be greater than 5. So this is the restriction on this, and this is important to know because sometimes you're going to solve equations. You're going to get an answer here, not for this one, but you're going to get an answer that actually doesn't work when you put it back in there. You had that with some square root equations. You went through, got an answer, and it isn't actually an answer. Just your method that you use produces it as an answer. We'll do one of those after. If you were to solve this, by the way, how would you solve this equation? Do I have to simplify anything first? Can I do this right away? 10 to the power of that, 10 to the power of that. This is one single term, right? This is in brackets, so it's okay, right? It's not two separate terms like it was up here. This was two separate pieces. I couldn't anti-log each one individually. This is one big thing, because so then I can cancel that. I get x minus 5 equals 100, right? So what's x? 105. Does this meet my restriction here? Is this okay with the restriction? It's okay, right? So that's an acceptable answer. Try thinking about what this means. It looks a little silly, but it's not as hard as you think. I'm going to stop that. There's little hints over at the right that you could try. Try thinking about using. Oh, this is good.